Hello everyone, welcome back to video lecture on OpenCV. This is the fifth video lecture you are watching. In the previous two video lecture we saw how to access or how to display an image along with how to display an frame of an video, either it may be from camera or maybe it's from a video file. In this video lecture we'll be learning how to access pixel information from image or maybe from frame. Imagine you are working in a project where your image size or frame size is nearly 1000 cross 1000. So if you are accessing a pixel information, the way you access the pixel information is not efficient, then the performance of your application reduces. So this is very important or crucial video lecture in this particular series. So let us learn how to access pixel information. So there are three ways of accessing, three methods. One is using ET, and one is using PTR, and one more is using a direct address calculation. So let us see the first method using ET. We are doing it for grayscale image now. We can use the ET for even color images. So I'm reading in grayscale image. The 0 indicates the grayscale image, and I need two loops. One is for rows and one is for columns. So this image dot rows, it is an attribute which gives you the number of rows in an image, and cols is one more attribute which gives the columns in an image. So here you can see the at. So image dot at, it is since image is of 8-bit type, it will be a uchar. So you need to give a uchar in the angle braces along with I comma j. And since you are displaying, you need to display it the integer format, so I am giving a type conversion. So this is for getting or accessing. If you want to set certain things or set zeros in this particular I comma j, you can do the same using at img.at, again uchar and I comma j, and you have to give a value 0, so it makes the pixel to be a 0. It means a black pixel. Next one is using direct address calculation. To do this, we need to understand how n pixels are stored in a mat. Let us see one more document. Here is my grayscale image arrangement of 5x10 image. Here is a 5x10 image. The attribute known as data for an mat type will points to the first memory location of an image. So it has 5 rows, 10 columns. And it has one more attribute known as step. It is an array. Step 0 stands for number of columns in the grayscale image, and step 1 indicates number of channels. Since grayscale image is 1D, it will have only one channel, so step 1 will be 1 and step 0 will be 10. So imagine you are at this point right now. It is pointed by image.data. So if you add 0 to it, you will be in this particular memory location. If you add 1 to it, you will be here. 2, 3, 4, 5, 6, 7, 8, 9. And when you add 10, you will be in the second row, first element. So if you add 20, you will be in the third row. If you add 40, you will be in the 30. If you add 30, you will be in the fourth row. If you add 40, you will be in the fifth row. So by adding 10, 10, 10, which is nothing but step 0, you can go to different rows. So that's the reason I have written here image.step0 into I, where I takes care of the rows. And imagine you are in this particular row, that is 0th row, where I is 0. If you add 0 to it, you will be here. If you add 1 to it, you will be here. If you add 2 to it, you will be here. So step 1 gives me 1. So 1 cross 0 will gives you here, and 1 cross 1 will take you to here, and 1 into 2 takes you here. So this is the way you are getting an address of particular position of the image. And this is for color image data. So the color image, if it's a 3 channel, it stores in this way. Each block will be of 24 bits. Here each block will be of 8 bits. If it is an 8-bit image, if it is an 8-bit color image, each block will be of 24 bits, and 24 bits is stored like B values, G value and R value. So image data will point to the first location. Number of rows is 5, number of columns is 10, and image step 0 is 10 into 3 because 10 columns are there. Along with each column will have 3 elements in it, so 30. The step 0 is 30, and step 1 is number of channels. Since it's a RGB image, it will be having 3 channels. Address, how do you calculate address? So image data will point here. If you add 0 to it, it will be at this particular position. If you add 30, it will come here. If you add 60, you will come here. So using this step 0, you can step to different rows. So that's what I have written, image step 0 into I. If you want to access the particular column, this is one column, this is one more column. So if you want to access column, again you require same thing, step 1 into J. So imagine I is 0, J is 0, that is you will be here. If you want to access B, the K must be 0. So K is accessed. If K is 1, you will access G. If K is 2, you will access R. And if you want to access the BGR of this, so increase J to 1. When J becomes 1, this becomes image data, this becomes 0, this becomes 3 into 1, 3, and depends on K. So if K is 0, this becomes 3 plus 0. So you will point here. If K is 1, the 3 plus 1, 4, you will point here. So in this way you can access even color images. So let's get back to our Word document. The second method is grayscale image access by direct going to address. That's what I just mentioned now. Image 0, so 0 is for grayscale, rows, columns, it is direct address calculation, step 0 into I and step 1 into J. This just gives you an address, and to access the content of that address you need to use a dereferencing. So after dereferencing, I am typecasting it to integer to effectively display on the console, and at the same time I am setting it using again a dereferencing operator and the address that you have generated. So let us see whether this works properly or not in the Visual Studio. So here is my program. I am checking whether the command line argument is less than 2 or not. If the less than 2, I'm printing an effective message, and if not, I'm reading an image which is a grayscale image, checking whether the image is having a data or not. If not, then again print error message, and if yes, it has a data, then display it in a window initial. And next I have two for loops. One for loop is for row and one for loop is for column. And here I less than 20, it means the rows less than 20 and along with the columns less than 20, I am displaying the content of pixels, and along with I am setting it to 0. It means I should get a 20 cross 20 black image in the right corner of the big image. So I have used at here uchar I, j to access it, and type conversion, and setting you just give a 0, no need of type conversion. So let me run this particular application, build it, Ctrl Alt F7, build successful, then run it. Yes, it works fine. You are getting a black image in the left corner which is of 20 cross 20. Along with that the value is getting displayed here. All are 255. The reason is you are working with a white image in this particular area. Let me go to second type using address calculations. So I'm reading a black grayscale image. Again, I less than 20, j less than 20, run through rows, run through columns. Here I am calculating the address using data, step 0 and step 1, and along with the dereferencing I am printing it, and I'm setting it the value 0. Again doing the same thing, which is nothing but giving a right black 20 cross 20 image in the big image at the left top corner. Let me compile it, Ctrl Alt F7, build success. So let me run it. So you are getting a black image in the top corner, and along with you can access the values. Let's go to third method, that is using a pointer concept. So here is my two for loops, run through rows and run through columns, and I'm using a ptr function, image.ptr, and you need a pointer of uchar type. Since your image is of uchar, you'll get a pointer of uchar in the ith row. If I is 0, you will get a 0th row. If I is 1, you will get first row, second row, third row, and so on. and in the left side you have a variable row ptr, which is a pointer of uchar type, and it points to each individual rows. And to access the values in the rows, you require a j, which is column, with a square braces, and you require a type conversion to display it on a console. And you don't require a type conversion to set the values to 0. Let us see the working of ptr function in the Visual Studio. So here is my ptr function uchar I row ptr, and I'm displaying it with a type conversion, and here is setting it to 0. Compile it, Ctrl Alt F7, build success, and run it. So you could able to see a black image in the left top corner and along with the console output. If you are working in C, then you, instead of having mat, you will be having IPL image. For IPL image, you have a function known as CV get 2D. You need to give a value attribute, give arguments image and I comma j. What it returns in a scalar. The S is a CV scalar type, and it returns RGB values. So scalar will be having 4 values inside it. One is RGB and one more is 0. So to access the first value, you have an attribute known as val. So s dot val of 0 gives you b, s dot val of 1 gives you g, and s dot val of 2 gives you r. And opposite to CV get 2D, you have CV set 2D to set certain things, and you need to give one more extra attribute argument s, which is a CV scalar type. Now let's go to a color image in mat. I'm reading a color image. One that stands for color image. Since it's a color image, I need one more for loop to run 3 channels. Here is my for loop with k, which runs for 3 channels. Here is for row, here is for column, and this one is for direct address generation. You need to add k extra, and this is same as the above one. You require a dereferencing to access the content, and even to set the content you require a dereferencing. Don't miss this dereferencing. Here is my C++ function. The image I am using is with resolution 819 x 460, so width is 819 and height is 460. I am reading an image. This I is for running throughout the channels, and j and k is for rows and columns. Less than 20 rows and less than 20 columns. I'm accessing and displaying it on the console, and along with I am setting it to 0. And in the bottom you can see I'm displaying certain other things to show that step 0 is actually stands for a number of columns into channel. I have created cout here, and along with, to show it for a grayscale, I have converted my color image to a grayscale using a function cvt color. It stands for convert color. It is a input, it is a output, and what type of conversion you require. It's a BGR to gray. If you require conversion from BGR to HSV, you have to give CV underscore BGR to HSV. It takes you to the HSV plane. And cout, it's for grayscale output. I am displaying step 0. Here you should get a step as 819. The reason is you have 819 columns, and step 1 should be 1. Here step 1 should be 3, because 3 channels are there, and step 0 should be 819 into 3. So let us compile this program. Ctrl Alt F7, build success. So let us run this. So you can see a black image in the left top corner, and along with 255 255 everywhere. And you can see for color image, step 0 is 2457, which is nothing but 3 times of 819. This is for grayscale. Grayscale, step 0 is for number of widths or number of columns, and step 1 is number of channel. Here number of channel is 3. So we have proved that step 0 is nothing but number of channel into number of columns. So let's go for one more method using et for RGB color image in mat. So you are reading an image, color image, and next here what you have to do is you need to split the color image into 3 different planes. One is B, G, R. So I am declaring a variable known as planes, which is of type vector. Vector is a STL library data type, and it is of matte. So if since the color image is 3 planes, the this plane will have 3 planes inside it, and all the planes are of type matte. I have a function known as split, which takes input RGB image and it takes a vector type. So when it splits, the plane 0 will be pointing to B and plane 1 will be pointing to G plane, and planes 2 will be pointing to R plane. So here is 2 for loops, runs through row, runs through column, and I'm accessing using at for plane 0. Plane 0 is for green, it's for blue. So at uchar I comma j of plane 0, you are displaying it in the console, and at the same time you are setting that particular values of I comma j of plane 0, which is nothing but B plane. So you are making B plane to be a 0, and if you want to display the changes of the image, so again you need to merge. So it's opposite to the split. So the merge, it takes a vector which is about planes and a RGB image as the output. So when it merges the 3 planes of a vector and gives you one RGB image. So let's see the program for this split. I'm reading in color image and creating a planes variable of vector of matte type and splitting it, RGB color, which is a RGB color image, and planes, which is of type vector, and I'm running through rows and columns, and I'm displaying it the value of B plane, which is plane 0, plane 1 and plane 2 for B, G and R, and using at function. And at the same time I'm setting here 0 0 0 for both all the 3 planes. So what I will do is I'll uncomment this, so that you are not giving a 0 to the B plane and you are giving 0 to the G and R plane. So you must get a blue square in the left top corner. So let us compile this, and again we are merging here at the end, so and displaying the color image. So let me compile, Ctrl Alt F7, build successful, and run it. Yes, I'm getting a blue image, square image in the left top corner along with the content. One more method is using PTR. So we saw the address generation for RGB and also using at in RGB, and next one is a PTR. Here again I require a row pointer of uchar type. You can get a row pointer using PTR method. For channel 0 again you require a splitting, and if you require one more row pointer for channel 1, you need to mention one more uchar type. A star row PTR1 is equal to plane of 1 dot PTR in angle brace uchar of I. So this gives the pointer for the first plane, the G plane. This is for B plane, and if you mention 1, you will get a pointer for G plane. At the same time you can access using J in angle braces, square braces. So let us see how this works in Visual Studio. So I'm creating 3 variables of uchar star type pointer to 3 rows. One row is of plane 0 for B, and PTR1 for G, and PTR2 for R. So and I'm displaying it on the console. At the same time I'm making them to be 0. So let me compile this, Ctrl Alt F7, and run this. Yes, you can access the pixel values. At the same time you can set the values too. So these are the different ways of accessing a pixel. So one is using at, one is using direct address calculation, one is using PTR. Accessing a pixel information is very crucial because if you are accessing some pixel which is not available in the image, you will surely get warnings or exceptions. So better learn this 3 methods of accessing a pixel. So that's it for this video lecture, and don't forget to subscribe my channel and don't forget to like the video. Thank you.